Okay, let's start with the review. I'm going to go ahead and do number 1, which is asking you to find p of negative 2 by using synthetic substitution. So that means that you need to plug in plug in negative 2 for x inside this equation, okay? But we're not going to do it the traditional way by plugging in negative 2 right there. What we're going to do instead is use synthetic substitution, which is where synthetic division comes from, okay? So it's going to look like this. I'm going to write in all the coefficients of my polynomial, which are 5 and negative 2 and 2 and 5. And I am substituting in negative 2. That's what they're asking us to substitute in. You do not change the sign. Notice that I put in negative 2 because this is substitution. They want us to plug in negative 2. Okay? If they had said divide by x minus 2, then I would put in a positive 2. That was where I would change the sign. But in this case, just leave it alone. So let's bring down the 5 and multiply. That's negative 10. I think you guys are very familiar with this process, so I can go a little quicker than usual. Negative 2 and negative 10 make negative 12. Negative 2 times negative 12 is 24. 2 and 24 makes 26. Negative 2 times 26 is negative 52. And negative 52 plus 5 is going to be negative 47. Okay? And that's my answer. Your answer is that final number right there, right? That's what we usually call the remainder, and we usually look for zeros there, okay? But that really is what your answer is. Your answer is p of negative 2 is negative 47. P of negative 2 is negative 47. That means that when you plug in negative 2 into your equation, into your polynomial here, you will get negative 47. You can try that, test it out using the traditional method, but that's what you should get. Alright, let's move on to number 2. It says divide and write the remainder as a fraction. So I need to explain to you guys what this means. So let's first divide, and then I'll show you what they mean by write the remainder as a fraction. Okay? So 6x to the 4th plus x cubed minus 9x plus 13 divided by x squared plus 8. We have to use long division in this case because we are dividing by something squared, right? This is not linear. If it was linear, I could use synthetic division. So we have to use long division is what I meant to say. We have to use long division because this is a quadratic. So we're dividing by x squared plus 8. And my dividend is 6x to the 4th plus x cubed minus 9x plus 13. Alright, and then we start checking, right? What you're doing is you're multiplying this times something that'll give you 6x to the 4th. Okay? So x squared times what gives me 6x to the 4th? And you should get 6x squared. And now multiply that 6x squared times both of these to see what you get, and you write them right here. Okay? So 6x squared times x squared is 6x to the 4th. 6x squared times 8 is 48x squared. Oh, did I make a mistake? I did. All right, perfect opportunity to show you guys a mistake that I made. 6x squared times 8, I made two mistakes actually now that I look at it. 6x squared times 8 is going to give me 48x squared, and if you notice, there is no x squared here, so I forgot a 0 here. Okay, I also forgot a 0 for that one. It should be x squared plus 0x plus 8. So I'm going to erase the whole thing and rewrite it again in order to get started. Here we go. Alright, so there you go. I rewrote it. It's 6x to the 4th plus x cubed plus 0x squared minus 9x plus 13, and it's x squared plus 0x plus 8 for the divisor. So we've got to start again. Same question though, what is x squared times what is 6x to the 4th, and you should have 6x squared here. So it's the same as we started with before. Now multiply the 6x squared times all three of those, and you're going to get 6x to the 4th, and now that everything should match. 6x squared times 0x is 0 x cubed, which is really just 0. You could just write a 0 there, but I want them to match, so that's why I'm writing 0x cubed. 6x squared times 8 is 48x squared. 48x squared. And now what you're going to do with these is you're going to subtract them. So we're going to subtract here. Now when you subtract, remember that negative sign goes with all three of them. So 6x to the fourth minus 6x to the fourth. That cancels. X cubed minus nothing is just x cubed. So that's going to be just x cubed. 0x squared minus 48x squared is negative, right? Negative 48x squared. Here we go. Bring down the negative 9x, and let's try again. What you do now is you again look at the first term, and you figure out what this times what gives me that. That was pretty simple, right? X squared times x gives me x cubed. So it's just x. Now take that x and multiply times all three of these. So that's going to be x cubed plus 0x squared. It's 0, really it's 0, but I'm going to write 0x squared so that it matches with the one on top, right? And then x times 8 is 8x plus 8x. And once again, we are going to subtract this. Minus. Make sure you distribute that negative so that you can do the operation correctly. So the first one is x cubed minus x cubed. That just cancels. Negative 48 minus nothing is just negative 48. Right? Since I'm subtracting 0, that means it stays the same. And negative 9 minus 8 is negative 17. X. Bring down the last one, which is 13. And let's do it again. Now again, you look at the first one here, you look at the first one here. X squared times what gives you negative 48x squared? And you should say negative 48. So negative 48, you're going to take that negative 48, multiply times all three of them, and you're going to get negative 48x squared plus 0x, or minus 0x, doesn't matter, it's still 0. 48 times 0 is 0. And 48 times 8 is going to give you a negative. That's going to be 4, 3, 8, right? 8 times 48, let me double check that. Yep, 384. Now we're going to subtract that again. Subtract that. The first one again cancels, what should happen. Negative 17 minus nothing is negative 17. That one does not change. So you have negative 17 right there. X. 13 minus negative 384. So that means 13 plus 384. So it's 384 plus 13, which is going to be positive 397. And at that point you're done because there is nothing else. You cannot multiply this by something that'll give you this, right? This degree is lower than that degree. So this is your remainder, okay? So what do they mean by write the remainder as a fraction? This is your quotient. That's your answer, okay? But in addition to that, you have this remainder. What they mean by write the remainder as a fraction is what you guys used to do back in elementary school. For example, let's do a simple one like 24 divided by 7, right? You would say 7 times 3 is 21. That gives you 3 because you subtract it. And you're done. Your remainder is 3. So you would write this as 3, which is this one. And from this, you would create a fraction, 3/7. 3 and 3/7. So 24 over 7 is the same thing as 3 and 3/7, right? That's what you're doing here. You're putting the remainder on top of the divisor. That's what they mean by write the remainder as a fraction. So this is your remainder. Put it over this. So it looks like this. Watch. This is your final answer. 6x squared plus x minus 48 plus, and then in a fraction form, negative 17x plus 397 over x squared plus 8. That is your final answer. You have the quotient and then the remainder divided by the divisor. You would do the same thing for number 3 and number 4. You guys should be able to handle those. Either long division, actually keep using long division. If you're going to use synthetic division here, divide by 5 first. Okay, because this should just be v, not 5v. Same thing here. If you're going to be using synthetic division, then divide by 2 first, so it's n plus 2 instead of 2n plus 4. All right, let's move on to number 5 together, though. That's the next one we're doing. All right, number 5, I'm going to do it using long division again, just like the last one. So I'm going to set it up. Notice that it's missing a few terms. It's x to the 4th, and then plus 0x to the 3rd, plus 0x squared, and so on, right? Let me fix this because it's too close. So I'm going to do it here. Now we have enough space. It's x to the 4th plus 0x cubed plus 0x squared plus 6x minus 25. There you go. And then on the outside, it's x squared plus 3x plus 5. There you go. That divisor is not missing any terms, right? It's x squared, 3x, 5. It's not missing anything, so no zeros required. All right, here we go. Now what you do is you figure out what this times what is x to the 4th, and that is x squared. X squared times x squared is x to the 4th, so that you need to multiply that x squared times all three of these right here. So it's going to be x to the 4th, x to the 4th plus 3x cubed plus 5x squared, right? You multiply times all three of them. And now what we're going to do is we're going to subtract it. We're going to take that and subtract it. Okay, the first one should just cancel. The next one is 0 minus 3, so it's negative 3, x cubed. The next one is 0 minus 5, so it's negative 5, x squared. Bring down the next one, plus 6x, right? That's that one right there, comes down. All right, let's do it again. X squared times what is negative 3x cubed? So it turns out that x squared times negative 3x, right, gives you negative 3x cubed. And once again, multiply that one times all three of them, and they go here. Negative 3x times x squared is negative 3x cubed. Negative 3x times positive 3x is negative 9x squared. And negative 3x times 5 is negative 15x. And now, again, we subtract. Negative 3x minus negative 3x, that one cancels, as it should. Negative 5 minus negative 9, that means plus 9. So negative 5 plus 9 is 4. 4x squared. Positive 6 minus negative 15, that's plus 15. So 6 plus 15, that's 21. Positive 21. Bring down the next one and do it again. X squared times what is 4x squared? That one should be pretty simple. It's just 4 plus 4. Take that 4 and multiply times all three of them. So it's going to be 4x squared plus 12x plus 20. And now what we do is we subtract again. 4x squared minus 4x squared is 0. That cancels out. 21 minus 12 is 9. X. And negative 25 minus 20 is negative 45. All right. And it looks like we're done, right? There is nothing else I can multiply this times that'll give me 9x. Okay? So this is your remainder. This is how I'm going to write my answer. Your divisor, x squared minus 3x plus 4, plus your remainder divided by your divisor. Okay, so your quotient plus your remainder divided by your divisor, plus 9x minus 45 over x squared plus 3x plus 5. And that is all. That's your final answer. Okay, so the next section I'm going to do is about polynomials, and it's asking us to determine whether the given binomial, this one, is a factor of this polynomial. Okay, and if it is, find the remaining factors. So let's go to number 7. I'm going to skip number 6. Number 7 is the same idea, but I feel like it's a little tougher, so I might as well do that one instead of number 6 for you guys. So number 7. This is the polynomial, and this is the binomial that they're asking us to check. We're going to check using synthetic division. Okay, so what I'm going to do is I'm going to take this and set it up for synthetic division. Make sure you check for zeros for the missing terms. So this one, for example, is going to look like this. It's going to be 2, 6, 0, -5, and -10. Right? And the 0 comes from the x squared that is not there. It's supposed to be an x squared between the 6 and the -5. And we're going to be dividing by -2. Right? Basically, we're trying to substitute in -2 to see if it works. Why -2? Because my factor that they gave me is x plus 2. So that would be a 0 of -2. Let's see if it works. Bring down the 2. -2 times 2 is -4. 6 minus 4 is 2. -2 times 2 is -4. That's -4. -2 times -4 is 8. That's 3. -2 times 3 is -6. And look, it does not work. So at that point, I guess you're done, because it says determine if it is a factor. If it is, keep going and find the remaining factors. If it's not, I guess you can stop. So it's not a factor. We're going to say not. X plus 2 is not a factor of the polynomial. I don't want to write the entire polynomial, so I'm just going to say of p of x. There you go. Alright, let's move on to number 8. It says Sabrina is building a rectangular raised flower bed. The boards on the two longer sides are 6 inches thick, and the boards on the two shorter sides are 4 inches thick. Okay, so you know what? To help me out here, I am going to attempt to draw a flower bed. Seems that it's rectangular, is what it says there. Like that. I'm not very artistic, as you guys know, but I'm going to try to make this. There you go. Something like that. That's a raised flower bed. It says the boards on the two longer sides are 6 inches thick. Okay, so I don't know which... let's just make these sides, these boards here are going to be 6 inches thick. Okay, so those are thick boards there for the to end the longer sides. And the boards on the two shorter sides, so for the let's make those boards 4 inches thick. Those are 4 inches. Okay, so they're thick boards, is what it's saying. So you know what, in order to remember what we just said, I'm going to write this 4 inches, and the red ones is 6 inches. Okay, alright, and now it says that Sabrina wants the outer length of her bed to be 4 times its height. Okay, you know what, I'm going to just go ahead and label the length, width, and height. So the height is, let's call the height x. And so that means that the outer length is 4x. Let's call this 4x. Also, it says that the outer width is 2 times the height, so 2x. That makes sense? That makes sense, right? If the height is x, and it says that Sabrina wants the outer length to be 4 times that, that's 4x, and the outer width to be 2 times that, that's 2x. Those are the outside measures. Also, she wants the boards to rise 4 inches above the level of the soil in the bed. So, the way I'm reading it, I'm understanding that this flower bed does not have a floor, right? Because it's on a garden, so it wouldn't make sense for it to have a floor. It's just boards that cover up a portion of the garden. But it says that she wants the boards to rise 4 inches above the level of the soil. So the soil does not fill up the entire flower bed. It stops about 4 inches before the top, right? The boards are going to be 4 inches taller than where the soil is. Okay, so let me try to zoom in and see if I can explain that in a little bit better. Let's say the soil ends right about here. Right, it doesn't go all the way to the top. That's where the soil ends. So that means that the height, the distance from where the dirt is to the top is 4 inches. That is 4 inches right there. I'm going to put that here. Right, that's what it says, 4 inches above the level of the soil. So the boards are taller than where the soil actually is. That's 4 inches. And it goes all the way, right? 4 inches, 4 inches, 4 inches, 4 inches. All the way across. Okay, I don't want to draw the yellow all the way across, but that's what it looks like. Alright, so now using that, and using the idea, the information they gave me that the volume is 3136, I know the volume is length times width times height. It says, what should be the outer dimensions of the bed if she wants it to hold 3136 cubic inches of soil? So the volume of all the soil, just the soil, is 3136. So what we need to do is figure out what the inner length, inner width, and inner height are. So this is the outer length, the outer width, the outer height. What is the inner length, width, and height of just the soil part? So let's start with the height. I think the height seems easier. The total height of the boards is x. We call that x. But remember we said that the boards are 4 inches taller than the actual soil. So what is the height of the soil part only? X minus 4. Let's put that there. So inner length is x minus 4. Not the outer length. The outer length is, inner height. Sorry, I messed up there. Inner height is x minus 4. How about the inner length? Let's go with the length next. Inner length. Here's the length. It's 4x, right? But the inner length, you gotta take into account the boards on the sides. How long are those boards? How thick are those boards, 6 inches. So the whole distance across is 4x, but take away 6 from each side, so it's gonna be 4x minus 12. There you go. For the inner width, the outer width is 2x, but again the boards, and these are different thickness of boards, that's why we're not using the same numbers. The thickness of those boards is 4 inches, so it's going to be 2x minus 4 is 2x minus 8. And when I multiply those times each other, all three of them, I should get the volume, which is 3136. So this is what my problem finally looks like. X minus 4 times 4x minus 12 times 2x minus 8 equals 3136. Alright, and now we're going to have some fun solving this problem, so get ready. Here we go. I am going to start by multiplying two of these binomials. Doesn't matter which ones you start with, okay, you're going to end up at the same spot. And these do not have any imaginary numbers or radicals, so there's no clue as to where we should start. I'm just going to go ahead and start multiplying. I'm going to start with these two, and I'll leave that one till the end. So 4x times 2x is going to be 8x squared. 4x times negative 8 is going to be negative 32x. Negative 12 times 2x is negative 24x. And finally, negative 12, we did that one. Negative 12 times negative 8 is positive 96. Alright, we need to simplify that by combining like terms. 8x squared minus 56x plus 96. And that's x minus 4. Now we're going to distribute the x minus 4 to the other one, just like we did before. So let's start with the x. X times 8x squared is 8x cubed. X times negative 56x is negative 56x squared. X times positive 96 is 96x. Negative 4 times positive 8x squared is negative 32x squared. Negative 4 times negative 4 times negative 56, that's going to be positive, right? Because it's a negative times a negative. Positive, what is 4 times 56? Let me see, that's 224 x. And finally, negative 4 times positive 96. That's going to be a negative. Negative 4 times 96, let's see, that's going to be 360 and 24, 384. Negative 384. Okay. Equals, let's not forget, 3136. Alright, let's simplify the left side by combining all the like terms that we see. So what I'm going to do is combine the negative 56x squared and the negative 32x squared. So first leave the 8x cubed. But this one and this one will be negative 88x squared. Next, I'm going to combine the 96 and the 224, right? Positive 96, positive 224. That's going to give me 300. Let's see, 4 and 6 makes 10. 2 and 9 makes 11, plus 1 is 12. 220. 320. 320x. Minus 384, because there's nothing to combine the 384 with. And now what I'm going to do is set it equal to 0. You can't solve it if it's in this form. It has to be in standard form, which means set it equal to 0. So I'm going to subtract 3136 from both sides. Like that. So I'm going to have 8x cubed. Now what I'm hoping for here after I'm done setting it equal to 0 is that I will be able to solve it by grouping. Because if it's not, it's going to be very difficult to solve. And all this messes from a different problem. It's going to be very, very difficult to solve. If it cannot be done factoring by grouping, we're going to have to use synthetic division and test a bunch of different factors. Now let's see, negative 384 and negative 3136 is going to give me negative 3000. That's 400, nope, 500. That is 520. Yes, 6 and 4 makes 10, 8, 11, 12, yes. Yeah, that's right. Equals 0. And now let's hope this works. I'm not sure actually if it works. We're going to try factoring by grouping. Again, if grouping doesn't work, that means that I have to look at 3520 and find all the factors of 3520 and test them all out, which does not sound like fun. But let's hope this works. I'm going to divide by 8 on the left one, the 8x cubed minus 88x squared. I'm going to divide by 8x squared. So factor out 8x squared, and you're going to get x minus 11. And cross your fingers and hope that 320 goes into 3520. I'm going to check it on my calculator right now. 3520 divided by... And thankfully it does, exactly 11 times. Alright, we got this. Factor out the 320 and you're going to get x minus 11 also. There it is, we found it. Alright. So since it's x minus 11 on both of them, that means that one of the factors is x minus 11, the other one is 8x squared plus 320. Equals 0. This one's going to give me x equals 11. Right? The other one is 8x squared plus 320 equals 0, which, as I said when I was introducing these problems, it doesn't really matter what that one is going to give you. It's going to give you an imaginary answer, an imaginary number. Look, you can actually solve it by subtracting 320. So it cancels. So it's 8x squared equals negative 320. Divide by 8. And you're going to get x squared equals negative 40. And then you're going to try to take the square root of both sides. And you're going to get an imaginary number, right? I radical 40, whatever radical 40 is, you can simplify it. But it doesn't matter because we're talking about a real world problem, a real world flower bed. And this answer here would not make sense in that situation. The only one that makes sense is that one. So x is the height, right? We said that the height is x. Go back and look. We said that the height is x. So therefore, the height of the flower bed is 11. Height is 11. The length is 4x, so 44. And the width is 2x, so 22. Those are all the outer dimensions. Okay. The inner dimensions, of course, are going to be different, but these are they're only asking us for the outer dimensions. That's your final answer. Okay, the next one we're going to do is number 9. It says a piece of rectangular crafting supply is being cut for a new sculpture. You want its length to be 4 times its height and its width to be 2 times its height. If you want the wood to have a volume of 64 cubic centimeters, what will be its length, width, and height? What will its length, width, and height be? So same idea, like the flower bed. Actually, this one is actually much simpler because there is no thickness of the walls. It's just a rectangular piece of crafting supply. There you go. Like that. There is no thickness that you need to worry about. You want its length to be 4 times its height, and you want its width to be 2 times its height. So we're going to call the height x. Right? Remember we talked about that. Why did I choose the height to be x? Because when they do that comparison, if you read from here to here, you're comparing the length to the height, and then you're comparing the width to the height again. So the one that gets compared twice is the height. We're going to call it x. Alright, using the height to be x, the length is 4 times the height, so 4x. The width is 2 times the height, so 2x. Length times width times height equals volume, and you want the volume to be 64. So yeah, it's definitely much simpler than the other one. Length times width times height equals volume. We want the volume to be 64. So x times 2x times 4x equals 64. And now we solve. Multiply these three and you're going to get x times 2x is 2x squared times 4x is 8x cubed equals 64. We're going to divide both sides by 8. I'm not going to write that down, but you can do it in your head. Divide both sides by 8 and you get 8. X cubed equals 8. So think you should be able to solve that in your head. What is the number that you multiply by itself 3 times that gives you 8? Basically, what is the cube root of this? And you should come up with 2. X equals 2. There is no plus or minus 2. The only possibility is 2, right? Negative 2 doesn't work. Negative 2 cubed does not give you 8. It gives you negative 8. You want 8. The only answer is 2. So x equals 2. So that is the, what did we say that x was? The height. The height is 2. The height is 2. The width is 2 times x, so 4. And the length is 4 times x, so 8. To test it out, let's multiply them together and see if I get 64. 2 times 4 is 8. 8 times 8 is 64. Yes, that's correct. That's your final answer. Alright, the next one I'm going to do is number 10. It says a natural history museum is building a pyramidal glass structure for its tree snake exhibit. Its research team has designed a pyramid with a square base and with a height that is 2 yards more than a side of its base. The volume of the pyramid must be 147 cubic yards. What are the dimensions? Alright, okay, so first of all, they're telling me that it's a pyramidal glass structure. The base is square. So this is what they mean. You have a square base. Pretend that that's a square. I know I can't draw a square perfectly. And it's a pyramid. So all of these corners go up and meet at a particular point up there. So it's a pyramid. The square base. The height is 2 yards more than a side of its base. Now, if the base is a square, that means that all the sides are the same. So if we call one side x, all of them are x, right? The length is x, the width is x, basically. The height of the pyramid, which is the distance from up here all the way down here, is 2 yards more than a side of the base. So if a side of the base is x, 2 yards more is x plus 2. The volume of the pyramid must be 147 cubic yards. What are the dimensions? Alright, first I must give you the formula for the volume of a pyramid, which is 1/3 length times width times height of the pyramid. Now in this case, since the base is a square, the length and the width are the same thing. They're both x. This is the length, this is the width. The height is that one. So let's plug all that in. They also told me that the volume must be 147. So 147 equals 1/3 times the length, which is x, times the width, which is x, times the height, which is x plus 2. And we're going to solve that. Alright, in order to simplify this, here's what I'm going to do. Notice the 1/3 there. I don't like it. I'm going to multiply everything by 3 to cancel it out. So I'm going to multiply this side by 3 because the 3 and the 1/3 will cancel. But I will also multiply this side by 3. And you can do that anytime you see a fraction that you want to get rid of. So that goes away. 3 times 147 is 441. Please double check my work. I make mistakes and I'm going to double check it also. 3 times 7 is 21, 3 times 4 is 12, plus 2 is 4, good, carry the 1, 3 times 1 is 1, plus 1 is 4. Yeah, that looks correct. And then what you have on the other side is, since the 3 and the 1/3 cancel, you have x times x, which is x squared, and you have x plus 2 inside parentheses. So to finish simplifying that, I'm going to distribute the x squared. So it's 441 equals x cubed plus 2x squared. Alright? Just like the last ones, in order to solve this, I need to put it in standard form, so I need to set it equal to 0. I need to set that equal to 0. So I'm going to subtract the 441. Subtract the 441. That cancels, so it's 0. X cubed plus 2x squared minus 441. Alright, and now we have to figure out the solution to that. Okay, the only thing I can think of that we can do is to try to do synthetic division to find the factors of 441. I do not see any other possibility that we could do. You can't do x factor because it's not a trinomial, that is a quadratic trinomial. You can't factor by grouping because you have 3 terms. Not enough. Yeah, the only thing I can see is that we're going to have to find the factors of 441. Let's list them all. 441. The factors are plus or minus 1, plus or minus, not 2, 3. 5, no. 7, maybe. Does 7 go in? I don't think so, but let's check. 441 divided by 7, 63, yes, plus or minus 7. I said 7, I just wrote 6, didn't I? 7. So 4 doesn't work because it's an even number. Even numbers are not going to work. We have an odd number there. 5 doesn't work because it's not a multiple of 5. 6 is uneven. 7, it works. 8 we can skip. 9, how about 9? 441 divided by 9. Yes, it does. So plus or minus 9. Let's hope we don't have to go that far. I'm going to start writing on this side. Plus or minus 441, of course. 3 goes into it 147 times. 7 goes into it 63 times. So plus or minus 63. 9 goes into it, how many times? 49 times, plus or minus 49. Are there more? How about 11? Let's hope we don't have to test all these. No, 11 doesn't work. How about 13? Also no. 15 obviously is not going to work because it ends in 5. Any multiple of 5 will end in 5. 17? Nope. 19? Hi. Okay, and the last one I found is plus or minus 21. 21 goes into it exactly 21 times because it's a perfect square. Okay, so we're going to go ahead and start testing some of these. I am really hoping that it's one of the first ones, like plus or minus 1 or plus or minus 3, one of those, or else we're going to be testing for a while. Okay, don't forget that this one has a 0 here, that's a missing after the 2. So when we try synthetic division, we got to make sure we write that one in. So it's going to be 1, 2, 0, negative 441. Here we go. Just really hoping that it's 1 or negative 1. Let's try. Bring down the 1. Oh, I'm looking at it, I'm like, no way it's 1 because the last number is 441 and there's no way we're going to get a giant number there. But anyway, let's try it. Bring down the 1. 1 times 1 is 1. 3. 1 times 3 is 3. That's 3. That number is way too small, so no. Let's skip around then. You know what? 1 is too small. We need something big because if you look at the last number, 441, we need to end up with a big number there. Let's go to, what do you guys think? all the way up to 21? Why not? Let's go to 21. Okay, bring down the 1. 21 times 1 is 21. That's 23. 21 times 23 is going to be a giant number, 400 and something. So it is a big number, but I don't think it's going to work here. Maybe we went too big. 21 times 23, 483. And that is way too big, right? Just 21 times 483. So yeah, I think we went too big. Let's go back a bit to 9. If we see that it starts working somehow, then maybe we switch it to a negative, but we'll see. Bring down the 1. 9 times 1 is 9. That's 11. 9 times 11 is 99. And that is 99. 9 times 99 is 891. Too big. Alright, so we're kind of making progress even though it's not working. Let's make it a little bit smaller. How about 7? And I think we are correct in sticking with positives, because this last number over here is negative and we need a positive here. So we keep sticking with positives. We're going to end up with the positive right there. Alright, so let's see. Bring down the 1. 7 times 1 is 7. That's 9. 7 times 9 is 63. That's 63. I'm hoping 7 times 63 is 441. I think it is. It is. Got it. Right, took us a few tries, but we got it. 7. That is our answer, guys. That is the answer for the side of the base, okay? Because our other answers are going to be either imaginary or they're going to be negative and they're not going to make any sense, okay? In all of these real-world problems, you're only always going to find one that makes sense, which is x equals 7 in this case. That is the side. So the length and the width are both 7. The height is 7 plus 2, which is 9. That's it. It's our final answer. Alright, I'm going to be skipping number 11 and number 12 and moving on to number 14. 11 and 12 are just like the ones I just did. So go back and look at 9 and 10 to see how those are done. Right? 11 is just like the last one, number 10. It's a pyramid. 12 is just like number 9. It's a rectangular box. Okay, so you guys should be able to handle that. And it doesn't have any thickness either, so it's one of the easier ones. It's not the one like the garden that we did before. Alright, let's move on to number 4. The instructions for these is to write a polynomial function in standard form that has these x-intercepts or these zeros or these roots. Okay, so 14, let's work there. They are telling me that the x-intercepts are negative 2i and 3 with the multiplicity of 2. Okay, so I'm going to go ahead and write all of the x-intercepts that I know for sure exist. Negative 2i, no multiplicity, so it only happens once. But it is an imaginary number, right? It is a complex number, so we need to include its conjugate, which is positive 2i. And then 3, but the multiplicity is 2, so there's 2 of them. Not 3 and negative 3, which is a mistake that some people are going to be making. Make sure you remember that for this one, this is a whole number. It's a real number. It's a rational number. You don't need a conjugate. These need a conjugate. Okay, so they gave you negative 2i, you include positive 2i. They give you 3, you only include again if it's a multiplicity. There you go. So now what we need to do is set up our parentheses. 2, 3, 4. X minus, x minus, x minus, x minus. X minus negative 2i is plus 2i. X minus 2i, x minus 3, and x minus 3. And now we need to multiply them out. We will start here, right? We got to be smart about this. We got to take care of those first, okay? So x times x is x squared. X times negative 2i is negative 2ix. 2i times x is positive 2ix. And 2i times negative 2i is negative No, remember I told you guys, let's try to do that one in our head without having to go through the middle process, okay? You should look at it and you should right away think 4. That one is 4, plus 4. And if you don't see it, remember you got to think first. 2 times negative 2 is negative 4. I times I is negative 1, because that's I squared. So negative 4 times negative 1 is positive 4. Alright, that's that one. We need to simplify it, actually. We got to keep going. So before I even touch the other ones, let's cancel these two, right? These are exact opposites of each other, so they go away. So it's just x squared plus 4. Okay? X squared plus 4. And now we're going to multiply times x minus 3 and times another x minus 3. Alright, next what I'm going to do is multiply the x minus 3 times the x minus 3. Let's do those right now. So I'm going to go ahead and do this part, and then whatever I get, I'll multiply times the last one. So x times x times negative 3, and so on. That's what we're doing right now. So let's go ahead and multiply x times x, which is going to be x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Put those together and you're going to get x squared minus 6x plus 9. Multiply that times x squared plus 4. Distribute again, and we're going to finish here. X squared times x squared is x to the 4th. X squared times negative 6x is negative 6x squared. Cubed, I mean. Negative 6x cubed. X squared times 9 is 9x squared. 4 times x squared is 4x squared. 4 times negative 6x is negative 24x. And 4 times 9 is 36. That's the last one. 4 times 9 is 36. Alright, now we're going to combine like terms. I see x to the 4th is by itself. 6x cubed is negative 6x cubed is by itself. 9x squared and 4x squared is 13x squared. Negative 24x is by itself. And positive 36 is by itself. And that is it. We're going to give it a name. Let's call it P of x. And that's what we call it, and that's what we get. And we're done. That polynomial gives you those x-intercepts. We're going to move on to number 15 now. We're going to do, I think, 2 more of these types of problems that we have been doing for the last couple of days. Okay, so they should look very similar to you guys. Alright, first I'm going to go ahead and write the missing root. I hope you guys are confident and familiar with coming up with the missing roots now. 0, negative 3, no conjugates for those. Those are okay. They're just real rational numbers. They're fine. But this one is irrational, so we must come up with its conjugate, which is going to be 2 minus radical 5. Remember, leave the rational number by itself alone. Don't change it, but change the sign of the radical part. So plus radical 5 minus radical 5. That means that I have 1, 2, 3, 4. So I need, again, 4 sets of parentheses. 1, 2, 3, 4. X minus, X minus, X minus, X minus. The first ones are pretty easy. X minus 0 and X minus negative 3, which turns into X plus 3. The other ones, just be careful. Remember that we need to distribute the negative. So we can write parentheses like I was doing in class, or you can go ahead and do this in your head where you just distribute the negative on your own. So for example, if I want to do this one, it's X minus, so it's going to be minus 2 minus radical 5. Like this. Because you distribute the negative. Same thing for the next one. It's minus, so it's going to be minus 2 plus radical 5. And now we start multiplying. We're going to clean this up. Make your life a little easier. This is just x. X minus 0 is just x. Right? The x plus 3 we're going to leave alone. You actually could multiply these two by each other already, and then just have it ready for when you finish this one. Actually, let's go ahead and do that. X times x is x squared. Here's what I'm doing. X times x and x times 3 and plus 3x. There. It's ready to go for when I finish with that one. So that's the one I'm going to do now. Okay. I'm going to make a box for that one. Like this. And I need 3 spaces. 9 total spaces, I mean. X, negative 2, and negative radical 5. X, negative 2, and positive radical 5. And let's multiply. X times x is x squared. X times negative 2 is negative 2x. X times radical 5 is x radical 5. X times negative 2 is negative 2x again. Negative 2 times negative 2 is 4. Negative 2 times radical 5 is negative 2 radical 5. X times negative radical 5 is negative x radical 5. Negative 2 times negative radical 5 is positive 2 radical 5. And finally, negative radical 5 times positive radical 5 is negative 5. Don't forget that you can do that in your head. Radical 5 times radical 5 is just 5, but it's a negative times a positive, so therefore it's negative. Alright, simplify by canceling as much as you can. That one and that one are opposites. That one and that one are opposites. So what you have is x squared minus 4x, because these two together make negative 4x. Positive 4 and negative 5 make negative 1. And then let's not forget that we still need to multiply times x squared plus 3x. And for that one, I'm not going to do a box. I'm just going to go ahead and distribute it. Okay. So x squared times x squared is x to the 4th. X squared times 4x is negative 4x cubed. X squared times negative 1 is negative x squared. 3x times x squared is positive 3x cubed. 3x times negative 4x is negative 12x squared. And 3x times negative 1 is negative 3x. And let's clean it up and we're done. X to the 4th is first. Negative 4x cubed is the next one. Negative x squared and negative 12x squared. These two together make negative 13x squared. And 3x cubed, oops, I messed up, didn't I? Let me erase that. Completely missed that x cubed. Okay, so x to the 4th, negative 4x cubed and positive 3x cubed make negative x cubed. Negative x cubed. Negative x squared and negative 12x squared make negative 13x squared. That was the same one I had from before. And finally, minus 3x. And there you go. Let's call this one f. F of x equals, and that is your function that has those roots. Alright, the next one I'm going to do is number 16. I think this is the last one of this type of problem where you're trying to come up with a polynomial from the roots. These are the ones that we've been practicing in class. Okay, so again, like always, I look at my roots and I figure out if they're missing any, because they're most of the time going to be forgetting one. Okay, I have negative 4. Don't worry about a conjugate for that one. But I have negative 7 plus 2i, and I do need its conjugate, which is negative 7 minus 2i. And so now I see that I only have 3 roots. Actually, this one's going to be much easier than the last one. 3 of them. Put in negative 4, so that gives you x plus 4 on the first one. For the second one, I'm going to do it in my head, but remember the negative here means that you change the signs of those. So it's x minus negative 7 minus 2i. So minus negative 7 actually makes it plus 7 minus 2i. The signs basically change. Same thing for this one. Minus negative 7 is plus 7 plus 2i. And now again, as always, we're going to be smart. We're going to multiply those first. Okay? You can do a box or you can just distribute. I'm going to go ahead and just distribute for this one. I think you guys are familiar enough with it that you can actually do it. So here we go. Start with x times x, that's x squared. X times 7 is 7x. X times 2i is 2ix. 7 times x is 7x. 7 times 7 is 49. And 7 times 2i is 49. And now finally the negative 2i. Looks like I'm running out of space, but I have enough over here. Negative 2i, I'm going to do that in red here. Negative 2i times x is negative 2ix. Negative 2i times 7 is negative 14i. And finally, the last one, which we'll do in our heads, negative 2i times positive 2i. Think. Do it in your head. You can do it. It's negative 2 times positive 2, right? That's negative 4. But it's I times I, which is I squared. That's negative 1. Negative 4 and negative 1 together make 4. Plus 4. Simplify this by combining all the like terms and canceling the stuff that you don't need. So I have x squared. The 2ix and the negative 2ix cancel. The 14i and the negative 14i cancel. Basically, all of the terms that have I in them cancel out. The 7x and the 7x do not cancel, so those add up together to make 14x. And the 49 and the 4 together make 53. Alright? Let's not forget about the x plus 4 that we have in the front. And we'll multiply those and we'll be done. So let's do it. X times x is x cubed. X times 14x is 14x squared. X times 53 is 53x. 4 times x squared is 4x squared. 4 times 14x is going to be 56x. And 4 times 53 is the last one right there, is going to be 212. Yes, that's right. Combine like terms to finish, and we're done. X cubed, 14x squared and 4x squared make 18x squared. 53x and 56x make 109x. And then 212. And that's it. Let's give it a name. Let's call this one G. Done. That is your polynomial that has those roots. Alright, let's move on to the next section. I think I'm going to do 19, 20, and 21 for this video, and then I'll continue with the rest with video part 2. Okay, so this will be the last 3 of this video. I think I can handle all 3, and we can do actually all 3 because these are do not take that long because it's factoring. It's something that is familiar to you guys, that you guys should be familiar with at this point. So here we go, number 19. X cubed plus 125 y cubed. It says find all the factor completely includes irrational and complex factors. So what they really mean by that is find the zeros, find all of them, and then write it in factored form with those zeros. So it's going to look, when we're finished, it's going to look something like this, right? Like we found the zeros and now put them all in factored form like this. So it's going to look something like that where all of them have factors. Even the imaginary ones and the irrational ones are going to be included. All right. So let's start by looking at what we have and see if we can factor something. That's what we're going to start with. And then from there we're going to build up to find all of our zeros. You should notice that this is one of the patterns that we learned. Perfect cube, perfect cube, perfect cube, sum of perfect cubes. Okay, so I'm going to rewrite this as x cubed plus 125 is 5 cubed, y cubed. And when I notice that all of them are cubed, that means that I can write it like this, right? Does that seem familiar to you guys? It should. You basically take out all the cubes and you just write x plus 5y. And then in the second parentheses, you're going to square the first one, that's x squared, Square the next one. I mean, multiply them times each other, but change the sign. So minus 5xy. And square the last one, which is 25y squared. Oops. Let me clean that up because that doesn't fit. 25y squared. No, I just noticed something. That is factored completely. We're done. We can't find the irrational factors here because they gave us an expression with two different variables. Okay, if it only had the 125 without the y cube, I could be able to keep going, right? I could solve this and say that x equals -5, and I could keep going with this one by using the quadratic formula. But because they put a y here, this is factored completely. There's nothing else that we can do. Unless, let me check. Let's look at this and see if there is a way to use the x factor there. I don't think so. Look, if I try to x factor there, you get 25 and -5, two numbers that multiply to make 25 and add up to make -5. Nope, doesn't work. So yeah, still it doesn't work because it's a difference of a sum of two cubes, right? And so like I told you guys, when you do that, that second part will not be able to be factored. So even if you have an extra variable there, it still doesn't work. So that's it. That's factored completely. All right, that makes our job a little easier when they threw that y in there. Let's move on to 20. 16 minus x to the fourth. This one we should be able to factor completely, even finding some that might be imaginary, some that might be irrational. So let's see. You should notice the pattern here. Perfect square. That's a perfect square, right? As long as the power is even, we consider it a perfect square. So we're going to split it up. The square root of 16 is 4. The square root of 16 is 4. The square root of x to the fourth is x squared. The square root of x to the fourth is x squared. Oops, did I mess up? Yes, I did. Minus x squared, right? I can keep going on this one because it's a perfect square minus a perfect square. So keep going. The square root of 4 is 2. The square root of 4 is 2. So 2 here. Plus, minus, square root of x squared is x. The square root of x squared is x. There you go. That's completely factored. But this one is not. This one right here is not completely factored. We can and we should keep going on that one. Because how many zeros, how many roots is this supposed to have? 4 of them, right? We only have 3 here, 3 parentheses. This one needs to be split up even further. This one is done, guys. We can actually solve them and find the actual zeros. This one will give you x equals -2. This one will give you x equals +2. Right? If you think about it and you solve that, that's what you get. Those are 2 of the zeros. But this one should give you two other zeros. So what you do is you set it equal to 0 and solve. I'm going to subtract 4. So I'm going to get x squared equals -4. Right? Take the square root of both sides. And I get x equals plus or minus, because when you take the square root, you have to include both the positive and the negative possibility. You should be able to do that. This is review of practice stuff that we did already before. What happens with the negative inside the radical? That's I, right? So that's an I that comes out. So then all you have is radical 4. The square root of 4 is 2. So you have 2i. That's 2i. Plus or minus 2i, which means positive 2i and negative 2i, right? Let's split them up because we do need them all split up. So there's 4 roots. These 2 and these 2. And now we can write the complete factored form. X minus, x minus, x minus, x minus. There's 4 of them. And just write them all in there. 2i, negative 2i, which makes plus 2i here. Negative 2, which makes positive 2. And 2, which makes negative 2. There you go. That is completely factored. Recap, the basic idea is to factor it as much as we can, find all of the roots, all of the zeros, and then write them all in factored form like that. And that is considered completely factored because each one of these gives you the solution. This gives you 2i, this one gives you -2i. This one gives you -2. This one gives you +2. Another one that we're going to factor completely, but we're not going to include any of those imaginary ones or irrational ones because it includes a y, right? So we're not actually going to find zeros or x-intercepts. But we can factor this, okay? 16x squared minus 40xy plus 25y squared. What you should notice is that if you just focus on the x's, it's a trinomial that we are used to factoring using x factor, right? If there was no y, there is a y, I know there is, but if there was no y, this would be 16x squared minus 40x plus 25. And that what we would be able to do, okay? And the same pattern that happens with the x's, which is this is x squared and this is just x, happens with the y. This is y squared and this is just y. This tells me that I can actually use x factor for this. As weird as it might seem, it's a trinomial, so it should work. So let's do 16 times 25. So it's -40, right? That's B. 16 times 25 is what? That's going to be 250, and 25 times 6 is another 150. 450? Let me double check that. My brain is, after 20 problems, is not working as well as it should. So let's see, 16 times 25, 400. I was way off. Yeah, 400. Oh yeah, that's right. It's 250 plus 150. It's 400, yes. All right, two numbers that multiply to make 400, but combine together to make -40. Not as obvious as many of the ones that we've seen, but you should be able to see that it's -20 and -20. Right? -20 times -20 is +400. -20 and -20 together make -40. And now you follow the exact same pattern we've been using. 16x squared is the first term, minus 20xy, right? Because the middle term is xy, it's not just x. Minus 20xy again, plus 25y squared, which is the last term, stays the same. And then you follow the same process, factor by grouping. Factor those, actually those include the negative, right? We're going to have to divide out the negative. So if you factor the first part, we're going to divide out 4x, right? That's what they have in common, 4x. So divide out 4x, and you're going to get 4x minus 5y, right? Look here, when you divide this by 4, you get 5. X is canceled, so all that's left is y. In this one, 16 divided by 4 is 4. The x squared becomes just x because you factor out the x. Do the same thing over here. These two have a negative. Remember, we need to factor the -5 in common. So divide out -5, and also what else do they have in common? Y. -5y. So factor out -5y, and what do you have left? That's going to be a +4x, right? Because the y's cancel on that first one. And then on the second one, it's going to be a -5y. And look, we have the exact same factor, 4x minus 5y. So it's 4x minus 5y and 4x minus 5y. They're exactly the same. You could leave it like that, I'm fine with that. But since they are exactly the same, we can write them as 4x minus 5y squared. And that is completely factored. There's nothing else to do. You can't actually find the zeros because you have two variables in it. Alright, and that concludes the first part of the video review. I will create a part 2. I don't know if that'll be tonight or tomorrow afternoon, but there will be a part 2 that will cover the rest of the problems. Okay, so good luck. Make sure you guys study, review, watch this as many times as possible until you get it.